In this lesson, we're going to take a look at position and motion. And these are things that we're pretty familiar with, but we do have to define them so we can understand the physics behind what we're going to do for the rest of this section. So position we tend to think of as where an object is, but position only makes sense if we have ways to measure it and describe it. And in order to do that, we need a reference frame. And a reference frame is simply an object or position that we measure from. We need a starting location. So if I want to say, if I want to describe an object's position or give direction somewhere, what I do is I start with a starting point. So if this is the point that we're going to measure everything from, I'm going to call it my reference point, then I can put an object 1 meter away from it. But if this distance is 1 meter, just the distance of 1 meter doesn't actually give me a position, because anything that's in this 1 meter radius circle, I didn't do a very good job with that, but anything on that circle is 1 meter away from my reference point. So the position needs a distance, but it needs more than a distance. It also needs a direction. So I could be 1 meter to the right, or I could be 1 meter below, or 1 meter to the left, or 1 meter above, or 1 meter at a 45-degree angle, but I need a distance and a direction. So position is distance and direction from a reference point. Okay? And the reference point can be anything as long as we have it identified, as long as we know what it is. Now, when an object changes its position, we say it's in motion. Okay, so if an object's position changes relative to its reference point, it's in motion. But that means we have to measure a change in position, and we can do that. We use change in position, we measure with a displacement. Okay, now we're going to get a couple different terms that students use interchangeably, and sometimes it's okay, and sometimes it's not. So these two terms are distance and displacement. And distance is what I set up here. Distance is a length. It's a length of a path, how far it is. So from here to here is 1 meter. From here to here is 1 meter. Neither one of those is a position. But I could say that this is positive 1 meter and this is negative 1 meter, and now they are positions because the positive and the negative acted to describe the direction. So that is a position. But what if I moved from this position of positive 1 meter to this position over here of negative 1 meter? Well, then I've gone a distance of 2 meters. All right, the distance between, let's call this point A and this point B, is 2 meters. But that is not the same thing as my displacement. So distance is the length of a path. But the displacement, if I walk from point A to point B, is negative 2 meters. Okay, the negative is a direction. Okay? Displacement includes a direction. So displacement is the distance and direction from start to end. Okay, so there's a subtle difference here in that it includes a direction, and this one does not. And since direction can be given as east or west or up or down or left or right or positive or negative, the displacement actually includes more information for us. Now it is important to notice that since a displacement is actually from start to end, from position A to position B, displacement is actually calculable. We calculate it, displacement, which we call delta x, is change in position. That's our final position. X is what we use for position, xf minus xi, so final position minus initial position. So I said that if we went from A to B, it'd be a displacement of negative 2 meters, and that's because our initial position is right here at positive 1 meters. But our final position, xf, is over here at negative 1 meters. So when I put this into my equation, I get negative 1 minus positive 1, which is negative 2 meters. Okay, that was my displacement. But if I walked from B to A, the other direction, started here and walked there, I would still have a distance of 2 meters. I'd go 1 meter and a second meter is 2 meters. But now, if I calculate my change in position, delta x equals xf minus xi, since I'm going the other way, my final position is actually the positive 1 meter, and my initial position is actually the negative meter. And so I have 1 minus a minus 1, and that's actually positive 2 meters. And so we can see from that that the displacement is the opposite when we move the opposite way. It's got the same amount, the same measure, 2, but it's got an opposite direction. This one is positive as opposed to that one, which was negative. So position tells me distance and direction. It can be signed. Distance is how far. Displacement is how far and what direction from beginning to end. It also will have a sign to indicate a direction. And something is in motion if its position is changing. And remember, all of that has to be measured relative to a reference point.